Last problem on the BC Unit 7 study guide gives us g of x as this function here. First thing it wants us to do is evaluate g of 0. If I plug in 0, I do get 0 over 0 indeterminate form. So it tells us to use L'Hopital's rule. So we want to take the derivative of the top and the bottom. Derivative of cosine of 2x is negative sine of 2x times the derivative of 2x. Derivative of the bottom is 2x. Plug in 0 gives me sine of 0, 0 divided by 0. Bummer. Got to do it again. Derivative of cosine, or sine of 2x is cosine of 2x times 2, and then we already have a negative 2 there. Plugging in 0 gives me cosine of 0, that's 1, so I get negative 4 divided by 2, which is negative 2. Part B wants us to find the first 4 non-zero terms in the general term of cosine of 2x. So let's do cosine of x, and then replace the x with 2x. So that's my function. My first derivative would be negative sine x, and then I've got negative cosine x, and then positive sine x. Plugging in 0, my derivatives are 1, 0, negative 1, 0, and then it starts to repeat because the next one is cosine x, and the next derivative is negative sine x, and so on. So cosine x is 1 plus 0 x minus 1 over 2 factorial for the x squared term. Next one, 0. X to the 4th has a derivative of 1. X to the 5th is 0. X to the 6th is negative 1. The general term here, notice I just have even exponents. So I'm going to make the exponent 2n. X to the 2n. If I plug in 1, I get 2. Plugging in 2 gives me 4. Plugging in 3 gives me 6. Plugging in 0 gives me x to the 0 here, which is good. Works for the whole thing. Notice the number in front of the factorial is the same as the exponent. It's going to be 2n factorial. We've taken care of the x part. We've taken care of the bottom. We just need to take care of the plus and minuses. Negative 1, if I make it just n, plugging in 0 gives me positive, plugging in 1 gives me negative, plugging in 2 gives me positive, and so on. So that's cosine x. It asks for cosine 2x. So replace all the x's with 2x. And also replace on the general term. So there it is. We're going to clean that up a little bit just for the next part. So answer to part B is 1 minus 2 squared is 4 divided by 2. Here I've got 2 to the 4th is 16. 2 to the 6th is 64. So there's our answer to part B, cosine of 2x. Part C wants us to use that answer to write the first 3 non-zero terms, as well as the general term of the Taylor series for g about x equals 0. So g of x, we just did this. We just did cosine of 2x. So I need to subtract 1 and then divide by x squared. So if I subtract 1, this 1 here goes away. That's part B. Part C. So subtracting 1 makes that go away. And now I divide by x squared. So it's negative 2 divided by x squared plus 16 over 4 factorial times x to the 4th minus 60, nope, divide by x squared, so that's x to the 2nd. 64 over 6 factorial x to the 4th, for real this time. Hopefully it only wanted 3 terms. Yep, there's 3 non-zero terms. And then we need the general term. I am dividing by x squared. So if I take this term and I divide by x squared, I'm going to split this part right here up a little bit. So I've still got negative 1 to the n. This is the same as 2 to the 2n times x to the 2n. I am dividing by x squared. So if I divide by x squared, you can either put an x squared on the bottom, and then when I divide, I subtract exponents. So x is going to have an exponent of 2n minus 2. Part D asks us to determine whether g has a relative minimum, a relative maximum, or neither at x equals 0. So if we have a relative minimum or a relative maximum, the derivative, the first derivative, has to be 0. So the derivative of this, so that's g of x, so g prime of x would be equal to, this would be 0. The 2 would go out front here. And I would still have x to the first. When I plug in 0, that becomes 0. The 4 would go out front. I'd still have x to the third when I plug in 0. So I do get a first derivative of 0. So it could have a min or a max at x equals 0. To tell if it's a min or a max, I need to know at x equals 0, am I concave up or am I concave down? So we need to check the second derivative. So the second derivative, first derivative makes that 0. The second derivative, we're going to be looking at this term right here. So the second derivative at x, my first derivative, I have 16 over, if I move the 2 out front, 4 factorial is 4 times 3 times 2. And then those cancel. Notice the rest of these, when I take the second derivative, I'm going to get 0 if I plug in 0 for x, because the first derivative is going to have x to the third, and the second derivative is going to have x to the second. So if I do this again, I move the 1 out front, subtract 1 from the exponent. The derivative is just 16 over 12, which is indeed a positive number, telling me that we are concave up, telling me we have a relative minimum. Justify your answer, I would state that g prime is equal to 0 and g double prime is positive.